Hello students, Mr. Courtney here. So in this lesson we're going to be looking at naming binary covalent compounds. We've already looked at naming ionic compounds. So we've looked at what happens when electrons are lost or gained. So when electrons are transferred. Today we're going to look at what happens when electrons are shed. We know that covalent compounds are formed when nonmetals share electrons. Okay, so we have nonmetals, which are on the right side of this jagged line. When they share electrons, they're going to create a covalent bond. Now, the smallest particle of a covalent compound is a molecule. So that means H2O, water. The smallest particle of water is a molecule. Now, we also have to be able to identify substances as being ionic or covalent, because when you're given compounds to name or to write formula for, you need to determine if they're ionic or covalent. How are we going to do that? Remember, covalent compounds contain nonmetals only, so the nonmetals are the elements on this side of the periodic table will be the ones found. Ionic compounds could also contain metals and nonmetals, so you're going to have one from this side and one from this side. Alright, if you look at it, CO2, you have carbon, which is a nonmetal, so that makes this covalent. Hg, which is mercury, and that is a metal, so that makes it ionic. N2O, nonmetal, covalent. Silicon, oxygen, two nonmetals, covalent. Platinum and oxygen, a metal and a nonmetal, so that is ionic. Strontium is a metal, so that makes this ionic. And if you want to we could take it a little bit further and go ahead and name these ionic compounds. Since we have mercury and chlorine, remember we keep mercury, change the chlorine end into IDE, so that's mercury chloride, platinum oxide, strontium bromide. Okay, just to refresh your memory on naming ionic compounds. Now let's look at some important facts about hydrogen. Now hydrogen only has one proton and it only had one electron. That means hydrogen, which also has only one energy level, only needs 2 electrons to be stable. Hydrogen can lose this 1 electron. It can donate it to become the hydrogen ion. It can gain an electron to become the hydride ion. So here it acts like a metal, and here it acts like a non-metal. And hydrogen can also share electrons with itself to form a diatomic molecule. Remember what diatomic means? 2 atoms joining together to form a molecule. And it's not just 2 atoms. Let me specify. 2 of the same atoms joining together to form a molecule. So here we see that a hydrogen can act as either a metal or a non-metal. We just mentioned that hydrogen is an example of a diatomic molecule. There are 7 in total. And if you want to try to remember it this way, I know I've written it backwards, but I bring clay for our new house. And if you look at the position on the periodic table, you start at nitrogen, go across 2, and then go down 3. And that will help you. And it looks like a 7 with the exception of hydrogen, which is over there in group 1. Alright, so binary covalent compounds are, the prefix binary means 2, so that means binary covalent compounds are those that are composed of 2 different nonmetals. And it has to be different because if they're the same, then they would be considered a diatomic molecule. Now, if you look at these here, 2 nonmetals can combine to create multiple compounds. That is, same nonmetals can combine to produce different compounds. So carbon and oxygen here we have CO and CO2, phosphorus and chlorine, PCl3, PCl5, nitrogen and oxygen, N2O4 and N2O3. So if we were to go ahead and use the same naming system that we used for ionic compounds, it would not work. And let's see why. Because we would say this is carbon oxide, carbon oxide. So these 2 compounds are different, but we're still going to name them the same. And that can't work. Phosphorus chloride, nitrogen oxide. No, that system cannot work. Now if you notice, you have different amounts of carbon and of each element in the compounds. So if we were to do it here, we have 1 carbon to 1 oxygen, 1 carbon to 2 oxygens, 1 phosphorus to 3 chlorides, 1 phosphorus to 5 chlorides, 2 nitrogens to 4 oxygens, 2 nitrogens to 3 oxygen. So here we see that they're combined in different ratios. So when we name these compounds, we have to use a system where we can identify the correct ratio of each element in the compound. And to do this, we're going to have to use prefixes. So we're going to use prefixes to show the correct number of elements in each ratio, in each compound, or the correct ratio of elements in the compounds. And you've used these prefixes very often. In math, for sure, you've done 1 through 10. We've used these when we named hydrocarbons. We have not used these in chemistry really, except you've seen tetra. Remember, tetrahedral. Good. So you should know these. And please ensure that you know these, because you will not have these on your test. You need to know these. So let's look at the steps to naming these binary covalent compounds. So first thing we're going to do is write the name of the first nonmetal. This is our first nonmetal here. We write the name, and that name is nitrogen. Then we write the name of the second nonmetal, and we change the ending to "ide." So oxygen, and we change the ending to "ide." So we get oxide. Then we add prefixes to specify how many of each element is present. We have 2 nitrogen, so we're going to use the prefix di. And we have 4 oxides, so we're going to use the prefix tetra. So we get dinitrogen tetroxide. Okay, so dinitrogen tetroxide. Now, let's look at the rules for using prefixes. We only use prefixes with covalent compounds. So when we did ionic compounds and we had CaCl2, we didn't say calcium dichloride. We just said calcium chloride. So we only use prefixes for covalent compounds. So if you're given the name of a compound and it has a prefix, then we know it's covalent. Mono. We never use mono in front of the first element when we name the binary covalent compounds. So CO2, is it going to be carbon dioxide or mono carbon dioxide? Remember, we do not use mono in front of the first element, so we do not use this. It will be carbon dioxide. Now, if there is an A or an O in the prefix, if it ends with A or O and you're going to put it in front of oxide, and I say only oxide, then you're going to remove the A or the O. If it's an I, you leave the I alone. So we have carbon monoxide or carbon monoxide. Again, we don't want these two. We need to drop these, so we get carbon monoxide. This is our correct answer. So here, all you're doing is just practicing what we just talked about, dropping the A or the O in front of oxide. So all you're going to be doing here is that you're going to drop the O, because you're going to put it in front of oxide, drop the A, 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 then you add the word oxide. So if you need to pause the video, go ahead, pause it, write them down, and then you can come back and look at the answers. Alright, so there you go. Here are the answers. Hope you did them correctly. And again, you can pause the video to take your time and look at them. Okay, so let's do another example of naming these binary covalent compounds, and I'm going to be doing it a little bit faster this time. So we write the name of the first nonmetal. That's chlorine. Remember, do not change the name of the first nonmetal. Just write its name as it is. We have 2 chlorines, so we get dichlorine. Oxygen, and we have 7. So that is hepta. Alright, remember, we don't put the A before oxide, so we drop the A, hept oxide. And that's your name. Alright, so let's go ahead and naming these. Carbon and oxygen. We have one carbon. So remember, we do not put the prefix mono in front of the first element, so we're not going to put mono here. So that will just be carbon. We have two oxygen, so that's dioxide. Second one, we have CS2, so that's carbon again, no mono at the front. Two sulfurs, so disulfide. Phosphorus. And we have three bromide, so that's tribromide. We have phosphorus again. And this time we have 5 bromides, so that's pentabromide. Now we have 2 phosphorus, so that's diphosphorus. 5 sulfide, so pentasulfide. Notice I'm not changing anything here. I'm not leaving this A out because it's not in front of oxide. Now some of you may be thinking you need to do that, but it's not. Only remove the A out of O in front of oxide. Alright, dinitrogen. Let me change the color here. Dinitrogen, because we have 2 nitrogens. We have 1 sulfur, so now it's monosulfide. It's on the second element, so we can put the mono. Silicon disulfide, because we have 1 nitrogen, 3 bromines. Nitrogen tribromide. We have 2 nitrogens, so that's dinitrogen tetrachloride, because we have 4 chlorine atoms. Okay, and there you have it. Now we're going to look at how we go from the name of the binary covalent compound to its formula. So we write the symbol for the first nonmetal, which is nitrogen, N. And we know the prefix is di, so that means we have 2 of it. Write the symbol for the second nonmetal, fluoride, which is fluorine. And we have tetra, so that's 4 of it. And there you have it, N2F4. That's your formula. Let's look at another one. We have phosphorus and oxygen. So that's P. We have 2 of it, so P2. Pentoxide, like in penta, so that's 5, P2O5. There you go. So here you can take a little practice going from the name to the formula. I'll go through a couple with you, and then I'll leave you. Then you can pause the video and work on the others, and then come back and look at the answers. So carbon tetrachloride, that's carbon. If I would write, so that's carbon. Chlorine is Cl, and you have 4 of it, CCl4. Let's do this one, dinitrogen monoxide. Dinitrogen N2 monoxide, O, just O. Disulfur hexabromide, S2, this disulfur bromine, and you have 6 of it, S2Br6. So you can pause the video and come back and look at the solutions. So here are the answers to these questions where you had to write the formula from the name, and that will take us to the end of this section. So until the next time, I'm out. Blessings.